Got it.
I think we
Okay.
are live.
I think so too. Okay. Perfect. Awesome. Awesome. Okay. Okay. Yes, you can take it away. I'll
Yes.
bring you
Hi,
back on.
everyone.
Hold on, hold on. Let me bring you to the screen. Sit. Wait. Pin you to the screen first. Okay. Take it away, Yash. Thank you.
Thank you, Sudha. Hi, everyone. Welcome to Weeklywed. Weeklywed is a speaker series which happens every Wednesday on AV, IoT, and AI. And now we are specializing in generative AI, bringing you speakers from all over the world who expertise in generative AI and other AI allied subjects. Today, we have a very special speaker with us. Before we dwell into the bio of the speaker, I would like to say that this session is recorded and this is live streamed. So it is, I leave the choice to you to be on video and speak up at times. So I would like to start the recording now.
Okay. Thank you, Yash. Yes, we don't need to do extra recording. It's automatically streaming, so that should take care of it. I think it's fine.
Okay. Hi everyone, welcome again to Weeklywed. Weeklywed is a speaker series which happens every Wednesday from 9 a.m. Pacific time, and we have speakers from all over the world who come here to share their expertise on AV, IoT, and AV, and now we have generative AI. Today we have a very special guest here, Kenechukwu, who has come from Lagos State, Nigeria. We are so honored to have Kenechukwu Agbo here. I would like to tell about Kenechukwu Agbo first. He's a machine learning engineer, a software engineer specialized in machine learning. Kenechukwu has worked in eBay and he is a Kaggle mentor. That is very nice to know. And he has many certifications in machine learning and is a subject matter expert in machine learning. Kenechukwu, we are so happy to have you here. And I am Yashaswani Viswanath. I'm a PhD student in machine learning here in Bangalore. And I have been hosting Weeklywed for quite some time. And I'm very happy to have got this opportunity to be hosting today. Welcome, Kenechukwu. And
Thank you
the
very much.
stage is over
Yes.
to you. I would like you to give a short bio of yourself because I know you have been achieving a lot more than what I told. And we would like to know more about you so that we can connect with you.
All right. Thank you very much, Yash. I think that was a very good introduction already, right? So my name is Kenechukwu Agbo. I'm Nigerian, right? And so I have been working in the AI industry for more than 7 years, but professionally it's about 5 years, right? So I have gone round basically from competitive machine learning on cargo to industry machine learning, deploying products. So working at startups doing machine learning, then going to a global company like eBay doing machine learning, right? So I started out building demand forecasting models for startups, right? So what I used to do when I worked at SnapNet was I used to just build models to help like airline tickets to predict their sales and help companies like breweries to predict the drink sales that they're going to get, right? So this was for startups. And I used to also work like the whole pipeline, right? From data gathering to the source to data cleaning, standardizing everything, training the model, and eventually deploying it. Then I moved to eBay. I was brought into eBay to work on recommender systems, right? So I worked on the AutoML part of the recommender system, right? So building the model, deploying it, so going like, so eventually learning the end-to-end cycle of recommender system. And that's what I've been basically doing for the past like 2 years of my life, focus on recommender system. So we started from the traditional model of building recommender systems, then eventually to the generative AI system, generative AI method. So that is currently my journey through the AI industry.
Wonderful, Kenechukwu. And it's very nice to know that you're a mentor. And I hope many students have benefited from your mentorship. And
Yes.
we would like to start off with Weeklywed. Hi, everybody. Feel free to introduce yourself. And we are all here, all ears to Kenechukwu. The stage is yours, Kenechukwu.
Sorry.
So that you're on mute.
Sorry, I became that person saying you're on mute. Oh God. Sorry, I just wanted to add one thing. Yash does our hosting, so she's going to be asking you questions, and it's perfect. But one thing I want to add is Yash actually has a she's doing her PhD now. Her master's in AI thesis was on recommender systems. And so she's like a perfect person to have this conversation. So I'm so excited to hear you guys. Thank you. And for those so people are watching on LinkedIn, so they will ask questions, or you can introduce yourself and comment there, and I will bring those questions and post in the chat here. And those who are here can be on camera or not, but you can also do the chat. Thank you, guys. I'm going to go off mute. Yeah.
Yeah, Kenechukwu, recommender system is an area that I like a lot, and I have extensively studied recommender systems. And it is nice to have been interviewing today. Yeah, not interviewing, sorry, hosting you today. Thank you.
It's fine. Well, I think it's a perfect match.
Yeah, you can start off, please.
Okay, so recommender systems, right? So the whole concept of recommender systems. So let me share my screen. If I can do that. So share screen. So if you can see my screen, please let me know.
Yes, we can see it.
Can you put it in slideshare? Okay. Yeah, in a slideshow mode so we can see the full. Yeah. Thank you. Yeah, thank you.
So the whole concept of recommender systems is something that is really, really important, right? For e-commerce, basically, not just e-commerce, but people that generally want to make sales. Because what we have noticed is that people don't buy things from e-commerce websites or applications or e-commerce stores basically because they want to buy. They mostly buy because you push them to buy. So I can imagine going into maybe a market in India or a market or like in Nigeria where we have a market, you walk into a market, maybe you have the idea or the purpose to purchase, let's say, food stuff, right? And then as you walk into the market, people start trying to flash things in your face, right? So look, I have wristwatches for sale. Look, I have toys for sale or whatever, right? Eventually somebody's able to get you to buy something else, right? Apart from the food stuff that you went to buy, right? It may even get to the point that you end up finishing the money you went to the market with. That's why some people say, I don't want to go to the market with more money than I plan on spending, or so that they wouldn't get into that kind of trap, right? So those people who try to market their products, they're kind of making recommendations, right? So here's what I have, come and buy this. Maybe they size you up, look at you from head to toe and say you're able to purchase this particular item, and then they flash it in your faces. So on the internet, in e-commerce, we want to mimic such a thing, right? We want to mimic such an attitude to getting people to buy things from us, to getting people to buy products, various products from us. So that's what we do. We flash items for our users or our customers who come visiting. Perhaps the customer has the plan to buy, maybe an Android phone, right? Then we flash various other phones, right? Or we flash chargers, Android chargers, or we flash Android earpiece. So to get people to buy stuff, right? And end up getting more than what they initially planned on buying, right? So recommender systems are very important. Why? Because you want to make sales. That's the summary of it, right? So in the recommender systems, there are various approaches we use, right? So how do we know which items to flash before users? It's very important, because if we just start flashing random items before users, it's not going to work. We have to know which items to flash before users to maximize sales or to maximize buying tendencies from these users. So those are the approaches that we're going to be discussing today. We have various approaches, right? So the important ones, right? So we have like 4 approaches that I'm going to be talking about today. We have collaborative filtering, which is very, very popular, right? We have content-based filtering. We have market basket analysis. And then finally, with the introduction of LLMs, we now have state-of-the-art LLM recommendations that we can make, right? So these 4 approaches all use different methods to get users to buy things, right? So I'll be starting off with collaborative filtering. It's really simple, right? Once you open your mind to understanding how all these things work, you'll notice that it's just common sense that we are trying to apply. Very simple things, right? So collaborative filtering, we have users that like a certain product, right? So in this place, in this my slide, I'm using Iron Man here, right? So let's say a user likes an Iron Man toy, right? User 1 likes Iron Man toy. Maybe the user rates it 5 stars, right? Rates the product 5 stars. Or perhaps an Android phone rates the product 5 stars. And then there is a certain user, X, who also rates this product 5 stars. So we are able to find that these 2 people are similar because they have the same interests, right? So if we want to recommend products to user X, right? We want to recommend which products do we recommend to user X. We look for user 1, who is quite similar to user X. We get what they like, the other product that they like, and make recommendations to user X based on these products, right? Very simple thing. So you, John, like a product. You, John likes iPhones, right? iPhone 13. And then we ask, how did you enjoy this product? The person rated 5 stars, right? And then Jane also liked iPhone 13. She also rated 5 stars. Then Jane comes on our website, our e-commerce site, right? Let's say Weeklywed Bay, right? Jane comes on Weeklywed Bay, and she wants to get products. She wants to buy something. So we want to know what to recommend to her. So since she likes a similar thing as John, and we notice that John likes Superman also, or he likes headphones, then we can also recommend these headphones to Jane. That's exactly what we are talking about when we say collaborative filtering. Take one person's likes, find who they relate with, and recommend it to that other person. That's the whole concept behind collaborative filtering. An advantage is that there's no domain knowledge needed. You don't really need to know about these products. You don't need to know what the details behind these products. Perhaps the iPhone has cameras, or it has a long-lasting memory or large storage. You don't need to know all these things. You simply pick the likes of a very similar person and recommend it. But the disadvantage is that it cannot handle new items. What this means is that if we introduce an item that we have not learned already, so for example, we know about Iron Man, we know about Superman. The only reason we were able to recommend Superman here is because we already know that we already know that John likes Superman, right? We already have this in mind. But if we get a completely new item, perhaps say skipping ropes, we do not know if John likes it or not. We're not able to recommend it. That's the disadvantage with collaborative filtering. We cannot handle new items. So there's an advantage in that there's no domain knowledge needed, but the disadvantage is that it cannot handle new items. That's how collaborative filtering works, right? So everything is basically a trade-off. Then apart from collaborative filtering, the next one we have content-based filtering, right? So content-based filtering is basically a technique where we take the content, the features of something, right? And then match it with other items that have similar features. Let's take, for example, the first item here. We have Apple iPhone 11, 64 gigabytes, black, A2111, then this. Or these are like various features. The phone is actually called an Apple iPhone 11, right? But we want to know the features because we want to use them for content-based filtering. That's why we introduce all these features, right? So by the time we concatenate everything, we have both the feature, the phone name, and then all the features that the phone possesses, right? So we have for everything, and then let's say we have an Apple iPhone 12, we can use something called a term frequency inverse document frequency. Now, I will not go into the detail, but it's simply saying finding a way to attach scores, right? So content-based filtering is find a way to attach scores to the content of an item that we are now able to rank these scores. So if we use something called the TF-IDF and attach scores to each item based on this, so we built something called a corpus, attach the scores based on these, and then we're able to rank them. So for example, the iPhone 13 will rank first, the Apple iPhone 11 will rank second, just like that. Then we take them and display them. So that's how content-based filtering works, right? So the content of these and the content of that, which contents match closely to this particular item. So assuming the customer clicks on an Apple iPhone 12, right? And we want to make recommendations. So we look for the phones that have similar content. The one before, which is collaborative filtering, the user clicks on an item. We look for another user that has a very similar character with this user and then make recommendations. But for content-based filtering, simply pick the item itself, take its contents, and then make recommendations based off that, right? So an advantage we have for content-based filtering is that we do not need the user data for this. We are simply dealing with items. We are not going to look up user. So which user likes this? So whereas in collaborative filtering, we're looking up users saying this user likes this. So we have to make recommendations based on that. In content-based filtering, we do not need to do any of that, right? So we can easily scale out to a large number of users because user data is not considered. However, the trade-off here, like I said, everything is a trade-off, right? So the trade-off in this case is that it requires item domain knowledge. So you have to take these items. We need to know that this particular item is black, this particular one is blue, this one is white, this one is black. So we need to know all these details, right? In order to make good recommendations. We clean them up, we arrange them appropriately so that we can attach scores in the right format and then make recommendations. So that's how content-based filtering works, right? So it's also a traditional method, just as collaborative filtering. Then a third traditional method that we actually use is, yeah.
I have a question here.
Okay.
The user data that we use in a collaborative filtering,
okay.
How is it taken? What about the privacy of the data, the user data? Do they give the consent? And do we use only that data or do we use all the data? Can you elaborate on the privacy aspect of collaborative filtering because users are involved and their data is involved?
Okay, so for the privacy aspect of collaborative filtering, so like you have rightly said, privacy is very important in everything we do. It's part of data ethics, right? We want to know whether or not we don't want to expose people's data without their permission. So it is very important for us before we take people's data, right, and try to use it for collaborative filtering, we need to seek consent, right? So when you go on a particular web application, you see things like consent, terms of use, all these things. So in these places, we want to state clearly that do you give us permission to be able to use the item, to be able to use your data for our algorithms, right? So we need to take consent. We need to get consent from the particular user. So in this case, so there are two cases. So a case whereby we can ask the user and say, okay, if we get consent from you, then we can make use of that. But there's another case where the user turns us down, right, and says, no, do not use my data. So in that particular case, we want to say, okay, that's fine. If we are not able to use your data, that's fine. So some people will go as far as saying, if we do not have permission to use your data, then we're going to limit some aspects of our website. But we don't want to do that, right? Because we still want that particular user to buy stuff from our applications, to buy stuff from our sites, right? So we simply have to take permission from these users for making use of their data or to build whatever algorithm we want, because it is very important. So, and in that case, that a user, we also have to be able to give users like permission to withdraw their consent. And in withdrawing their consent, we need something like, say, a machine unlearning to be able to remove that particular user's data, because we cannot train afresh. We need to be able to take out that user data. So there are two aspects: getting consent from the user and giving the user the ability to withdraw their consent at any time, right? And so that is how we want to approach this concerning privacy. Does that answer your question?
Yes. I have a follow-up question.
Okay.
If the users do not want the recommendations and they are okay with going over the entire product list, is there a mechanism by which we can do that? And the second part of the question that I have is, in the collaborative filtering, if we do not have the user data, that is, we do not have, it's called the cold start problem in recommender system, where we do not have the user data, how do you tackle it?
Okay. So let me start from the first question that says, sorry, what was the first question? So sorry, I'm not sure. I've forgotten the first question. Sorry. Sorry, can you repeat like the first question, please?
Yeah, cold start problem. How do we tackle cold start problem?
No, I think that was the second one.
Okay, the first one is, in case the users do not want to have the recommender system and they want to browse all the products, will that be an option?
Okay, so actually it depends on your web application, right? So the user does not want recommendations, right? And the user wants to browse all the products, right? So for a web app, for a site that has just few products, I think it will be possible, right? Now I'm giving purely based on my opinion in this place, right? So for a site that has just small data, small products, right? We can actually let the user go through our catalog. But for something like, say, for a large site like, say, eBay, right? Then I'm not sure that we are going to be able to display everything, right? So the user may be able to take on some products. We just get out some products, display to the user, and then let it slide. Right? So that's what I believe concerning a user that does not want recommendations, right? Because I work basically on recommendations. So getting a user that does not want recommendations is something that is kind of new to me, right? But I'll say show some products and let the others go, right? So that is my idea for tackling users that do not want to recommendations. Yes, Sudha, you're raising your hands.
Yes, so I just wanted to add something, having worked in e-commerce and also thought designing AIX design. So a machine learning engineer like Kenechukwu would build the recommender system. So when you build product, what happens is, of course, it is dependent on the website or the app, how they want to design it, how inclusive they want to be of the user who's not giving consent, to give them the experience, right? So the easiest thing is you will get a feed from the recommender system and you just use that to show the experience of the user. But if the user is not logged in, and if they are not cookied, so you don't know who they are, then we would give a different kind of flow, as if they are first time users. So they'll kind of go through the browse, which is allowing a limited set of products, or they have to scroll and scroll and scroll, which is, not the most optimal experience. Or they would use search, and then only based on their search with their keywords, they will find what they want. It might not be as optimal as the collaborative filter, which knows more of their past preferences and then gives them the optimal. At least that's our belief system. When we are using AI to do this, we think AI is going to do a better job than the user just going
Yeah,
searching for something. So I
yeah,
just wanted to add that. But there will always be some users, before they develop trust with the particular site or brand, who might just not want to log in yet and do a little amount of search versus browse. So they switch between search and browse a lot. That becomes their experience. And so, having has somebody who has worked in analytics, I can see that that would be the user experience. It's not a it's suboptimal user experience, but eventually the customer gets trust, and then they would end up giving consent to use the data and get to collaborative filtering. So thank you for letting me add that. I'll let you go back to the other question on the cold start problem. That's very interesting, because anybody who starts a startup, anybody who's trying something new, or even Yash actually was teaching at Elisava University about how to build collaborative filtering. She was teaching clustering recently and recommended systems. So anybody, even a student. So we are hoping one of our students is watching this and they would like, we don't have data. Where do we get started? So cold start problem, I'll pass it back to you. Thank you.
Okay. Thank you very much for that, Sudha. That was mind blowing. It shows your experience also, right? So yeah, so we're like so many experienced people here, not just me. Thank you very much. Okay, so for the cold start problem, right? So you said, what if there is no user data, right? And so we have a cold start problem, right? So the best way I know to tackle a cold start problem is to just ask, right? So cold starts is when we don't have like the user data, so we're not able to say this user likes this one or this one likes that one. We could just ask and say, rate this product, right? Or do you like these products? Or we could just, send that direct questionnaires, right? That's like the best way I know to handle a cold start problem, right? So ask the question directly, send them, would you consider buying this over this? Or do you like um what would you rate this product? Have you used this product before? They also buy this. Would you buy this or would you buy that? So we're able to generate data when we ask, right? So that's the best way I know when tackling a cold start problem. Ask the question directly, right? So that's how I would address a cold start problem, basically. So that's how I would do. Also, there are also various ways, but that's the best one I know.
Kenchiko,
Yeah.
I have a doubt here.
Okay.
Thank you for the detailed explanation that you gave about the privacy concerns, about the cold start problem. The question I have is about the long tail problem, where we have the products and the popular products keep getting higher ratings and the popularity goes on increasing, whereas the ones in lower demand, they do not get the good ratings.
Okay.
How do we tackle this so that, see, as a seller or as a platform which is supporting the sellers, we need to have a fair mechanism to uh, show all the sellers. If only the products that are the best and they're getting good ratings, they keep getting showed. What about those products which do not have good ratings? Even those products are important.
Okay, yeah. So this problem for products that do not have so there's an imbalance being created, right? Some products get very good ratings, some are not getting rated, but they are also important, right? So that's the frame of the problem, right? So a way to tackle this, right? We can use is the same strategy we would use of tackling trendy products, right? We need to have a we need to have we can set a strategy is to set a time-based expiration, right? A time-based method for trendy products, right? So if your products keep trending, so we measure the trend and then we expire the trend, let's say in maybe we can take 48 hours or so, right? Or 72 hours. We can use a time-based technique to expire trends. And then if this that way, everything comes back to normal. And then if they trend again, well, it means they are doing something right. They keep going up. But what matters is that we are able to give other products the chance to trend it, to rise and get good ratings also. So by having a time-based expiration for really top products where we reset everything. So that will tackle the problem of products always getting high ratings and the others remaining low. That will handle that.
Thank you for your explanations.
Thank you. So that explains that, right?
Yes, yes.
Okay. So do you have any other questions in collaborative filtering?
I have heard about the term filter bubbles.
Filter bubbles. Ah, okay. So I'm not so deep into filter bubbles. So if can you like break down what it means so that I know?
Sorry, Kenechukwu, can you stop sharing so we can see both of you?
Okay.
This is fantastic discussion. Awesome.
Okay.
Yes, do you want to tell us what is filter bubble?
Filter bubble and echo chamber. So this is where the user ratings, the user ratings that is given. So I'm not able to get it, but I have heard the term filter bubble and echo chamber.
Okay. So not sure what an echo chamber. I've not really heard the term before, but perhaps I know the concept. So if you can explain that, but that's fine.
I will come back to it. Maybe you can move to the next portion.
Okay, all right, that's fine. So I share. Okay, so for the collaborative filtering, so that's how we approach that basically. And then the content-based filtering, like I said, we're able to get the products, the content, the features of these products, and then make our recommendations. We rank them using like a TF IDF. So we can use other things like word to vec, right, and make predictions. But to keep it simple for this, I'm just using a TF IDF for that. Then apart from content-based filtering, we also have something we call market basket. So while collaborative filtering and content-based filtering are tailored towards similar items recommendations, market basket is tailored towards complementary items. So market basket basically says the people that bought a particular product also bought bought something else. Like now we have 4 users here. We have user 1, user 2, user 3, user 4 buying an iPhone, and those same users buy an AirPod, right? So if user X buys an iPhone, we also want user X to buy an AirPod. So basically it's saying items that go together. So we want to get the items that frequently go together, irrespective of their taste or similarity between people that bought these items, right? So we use it for complementary items recommendation. So while collaborative filtering and content-based filtering are used for similar items, market basket is used for complementary items. So the advantage is that we do not need user data, so it's easier to scale to a large number of users in this case. So the user data I mean is like what user likes and all. We simply just want what they bought, right? So the disadvantage is that we don't have insight into the relationship. So we cannot tell why people are buying the products. We're not able to do an analysis and say, these are the reasons people bought these products, since we're just simply picking what they bought, right? So that's the disadvantage behind market basket, but it's being used for complementary items recommendations, right? Now, so these are traditional methods that I have explained, these 3 methods. Now, apart from these 3 methods, we have something else, right?
So, Kenechukwu, I have a question here about market basket analysis.
Okay.
So when we have a e-commerce platform and we know that there are certain items that go together, what about the temporal nature of these? Will they change over time, or over time will they always be same? And that is how you can do the recommendation.
Okay, so will they change over time? This is a very good question, right? So we can have a technique to basically know what to show, items that go together. So we can cache like maybe responses, because we don't want to go through how this would work generally is we pick items from a particular item, like from if the user clicks on an iPhone, for this example, we pick the iPhone, find out all the users that bought these iPhones, right? After getting the users that bought these iPhones, we take these users, right, and look for what else they bought, usually within a time frame. We don't want it to be like to go too much, like to go out of time, right? We take what they bought and look for the other things that they bought, then rank them, count using the count. So the number of people that bought a particular item. So at the end of the day, we're going to have items that go together. So we can decide and say that for the next, we can decide and say for the next, we can cache this response for these items that go together for the next, let's say 1 week or 2 weeks. We want to cache them. So for the next 2 weeks, these particular items will be, say, items that go together. Then after it expires, we rerun our algorithm when somebody clicks again. So yes, it's going to be changing, but that will be when the cache has expired, when we have finally gone past the time period we set to be able to pick just these items that go together. So does that answer your question?
Yes, Kenechukwu. Now, when we talk about the temporal nature of the data and the recommendations that we give, I have a very important point here that I would like to bring to your notice, and that is there are certain points of time, like a holiday.
Yeah.
On a holiday, say Christmas vacation, and there will be always a high demand for certain kind of gifts or certain kind of items. So we call this trends.
Yeah.
So can you tell about trends and how we can recommend using trends?
Okay, so how we can make recommendations using trends. So like you said, so during holidays, let's say Christmas or so, we usually experience like a bust, right, or a boom in the sales of some items, right? So these particular items that we have experienced a boom in, these items are going to rank high if we take the count. Using the count of the items that have been bought during these times, we can use this to build a market basket or a recommendation algorithm or a recommender system to recommend these items that have experienced a boom. So we basically use the count of these items that have been bought to make our recommendations. So how this would work is if the user comes and clicks, maybe okay, the iPhone just dropped, iPhone X, or let me say iPhone 15 just dropped, right? And then a user clicks. So, okay, I don't want to use iPhone 15 just dropped. Okay, it will still be a very important time. It's going to create a trend, right? But let me just use something like maybe iPhone 15 drops on Christmas Day, right? So now iPhone 15 has dropped on Christmas Day. Lots of people are buying iPhone 15. So iPhone 15 now has a high number of counts, right? So what this means is that if a user clicks on iPhone 14, we need to also fetch iPhone 15, right? Using the count of the items the count of the purchases that have been made on iPhone 15, right? But that's going to last, like I said, time period. We have to have a time that expires all these periods, right? So when we take that into consideration, that because of Christmas, this is Christmas time, what we want to fetch from is not directly from collaborative filtering or directly from content based, but we want to pick from trends, right? Users are experiencing high counts. Then we're going to use that as our recommendations. That's how we can go about handling trends. Does that answer your question?
Yes, thanks a lot, Kenechukwu. And I would like to come back to the discussion of filter bubbles and echo
Okay.
chambers.
Okay.
It is about personalization. Say somebody
Okay.
sees, for example, they see sunscreen and
Okay.
they click on sunscreen. So they keep getting sunscreen products shown. But what about other products, other makeup items, such as
Oh,
powder,
okay.
where we need to go out of the filter bubble? How do we tackle that?
I just want
Okay.
to add one more thing. I know we are discussing all the methods of recommender systems, collaborative filtering, using e-commerce because that's a strong suit and it's a natural. But the word filter bubble, I think, came from social media because if I like something and I do the like on that, and I have similar friends, then it kind of puts me in a bubble and I see similar things and it kind of reinforces my belief that this is what is happening in the world. So news actually we get into a filter bubble. So I just wanted to give that in context. But that example Yash gave of I come searching for something and ask for sunscreen, then how do you get me out of that bubble to buy related items or something else?
Okay. Okay, that's fine. Okay, so I like that question. So it all depends on our design, right? Now, when we are making recommendations, if you generally go on e-commerce sites, right, using eBay, because that's where I worked, right? So using eBay as an example, if you go on e-commerce sites, you're going to see different sections, right, that contain different types of recommendations, right? So it's not all our recommendations will not come from one side, right? We want to be able to have, so a section on eBay would say related items. A section would say sponsored items. A section would say people that bought this also bought this, which is complementary items. So filter bubbles, when somebody clicks on something, filter bubbles are more likely to affect similar items than they are to affect complementary items or maybe sponsored items, right? So having different sections of compartments of recommendations, different compartments of recommendations can help the user. So the user does not just see a particular item that is similar. The user also sees the user does not just keep seeing sunscreen. The user also sees some other like complementary items and all. You can see them below. So that's one way. Another way we can actually approach this. So if you listen to what I said about content-based filtering, right? I said we're going to need as many we're going to need as many features as possible, right? So if I scroll back to content based. So for example, you see this Apple iPhone 11, right? Apple iPhone 13. So if we have Apple iPhone 11 and then a user clicks up or user searches for Apple iPhone, we're going to keep getting Apple iPhone, Apple iPhone, Apple iPhone. But if we add as many features as possible, then it's going to vary the ranking. Right? So this ranking of Apple iPhone 11, Apple iPhone 13, Apple iPhone this will only happen when our features are not enough. They're just very limited. So Apple iPhone 11. So that's when it's going to happen. But if we add as many other features as possible, when we are ranking them in term frequency, right? Then the recommendations will vary. That way, we do not just get iPhone um, Apple iPhone as our recommendations, right? Now, another way again is we can recommend based on categories, right? So we're not just picking items from Apple iPhone, we're also picking items that are basically in cell phones and accessories, right? We can pick items from them. So we are not just we're not just saying go there, pick iPhones. We're saying go there, pick items that belong to this accessory, that belongs to this category, and then rank them. That way we're going to have varying recommendations. Do you understand what I'm saying?
Yes, yes. These are wonderful thoughts and very good ideas, I must say, which uh, you are coming from an experience where you
Yeah.
have deployed real world models. And
Yes.
this experience is adding value to the session here, and we are happy for that. And Kenchukwu, um, maybe you can go to the LLMs and we will go over the problems again.
All right, that's fine. So for large language model, this is like the state of the art, right? This is currently what we do, right? Lots of companies, lots of e-commerce companies are going into large language models right now because of the advantage, right? We don't need large amounts of data that we need for like collaborative filtering and content-based filtering. So we just simply create prompts, right? So we say you're a shopping assistant, tasked with recommending products for users based on what they click. Please ensure that so basically make recommendations. You're going to get an example, or you're going to get examples of inputs, and this is how the output should be. Please ensure that the recommendation response is polite, warm, without racist or sexist response, because we want to avoid that as much as possible. So we get our examples. We say, can you show me similar iPhones with good cameras I can buy? So we also want the context. So context is, it is Christmas. Of course, the user is not going to type in the context. This will be gotten from you programming it, right? And the output is sure. So you're giving it this example. Sure, here are some really nice similar phones with good cameras you can buy for Christmas. So we want enough examples, like say 100 or so, right? And then when we do this, so we're concatenating everything. Say, now do this. Input, I'm looking for complete gym equipment. So the context is customer search history contains headphones. And we send this to the LLM and then we wait for the output. So because we have given inputs and outputs, the LLM is going to get outputs that match. So for what it has learned, so zero-shot learning, what it has learned from the inputs and the output it gets, and then it's going to give you output. So you have to match those outputs to your product catalog. So like I said now, the disadvantage here is that it can generate products that are not in your product set. So that's the trade-off with this issue. Right? So how it works is you get your prompt, you create examples, as many examples as possible. When a user types in maybe types in a text requesting for something, you simply take that text. You can then use something like, say, a KNN or so to find the closest examples that match the user's text. Concatenate everything and send everything to the LLM basically, and then wait for the result. That's how we can go about this using LLMs. That's how LLMs work. So the advantage is that we do not need large data. We have zero-shot learning, and we can learn from that. Then the disadvantage is that we can generate products. The disadvantage is that you may generate products that are not in your product set. So you need to have a filter. So it's about, so while in the others, you are sure of getting products that are in your product set. In this particular one, you are not sure of getting products that are in your product set. So you need to handle the outputs. You also need to filter the output. That's how large language modeling works for our recommendations. Do you have questions on this?
I was just thinking if we can bring in content-based filtering and try to put large language models and do content-based filtering or collaborative filtering um, by actually taking the contents from the products that are there and the user ratings that we get, like a real-time system. And
Okay.
those parameters, if they can go and query the large language model and get the prompt, what is your say on this?
Okay, so it's a very fantastic way. Your what you have just said now is very, very good, actually. You can take content based, you can take collaborative filtering, and then we send this, we use it to query the large language large language model, basically to get our response. I like that idea, right? But now I think one thing with all of this is that we need to be wary of time, right? The reality of machine learning and AI is that we can keep getting better and better algorithms, getting better and better results. But an issue we have is that we need to meet latency, right? There are latency requirements. So imagine a user goes, because content-based filtering or collaborative filtering is an entire process on its own. So a user goes to your Weeklywed day and clicks on an item, and then the user is waiting for like 5 seconds before they get their recommendations. The users will not really have that kind of patience. I know I will not, right? So yes, your idea is very fantastic. It will work, right? But what is the latency? What the hardware required to run this is going to be very expensive. So at the end of the day, you may find out that you're spending more than what you're going to make or what you're going to generate. But if it is based on theory, yes, it works. The question is whether it works when you put it into production because of latency. Users are not that patient and we need to keep them, right? So I've had some models I have built, right, that we're not able to deploy simply because they go past the latency. They have to find a way to dumb it down. They have to find a way to, even though it means losing performance, we have to find a way to bring it down, right? And then we're able to use that to get our users to make our recommendations. The models, it doesn't mean the models will perform poorly. They'll still perform well. We have an allowable performance, so rather allowable latency. You define the latency you want that is allowable, then you work to increase your model as far as it's within the confines of that. So yes, theoretically it works, but since these are two separate processes entirely, I think it's going to be really expensive to put that in production. That's my opinion there.
Kenechukwu, one important question that bothers me is what are the metrics that we use to evaluate these recommender systems? Yes,
okay,
get the recommendations, but to know how well they are faring, what are the metrics?
Okay, so we have two types of metrics, right? We have offline metrics and we have online metrics, right? So for offline metrics, offline is basically how you want to estimate the recommendations while you're building it. Then online is when you have deployed it, right? So offline, we can use something like, say, the NDCG, right? Non-discount count gain, right? What it basically means is that you penalize items that are rated highly but are not clicked, more than items that are rated low but are clicked, right? So if you're basically penalizing you're basically penalizing, it's better for you to not recommend something that is wrong than to recommend something that is right. So we have that is one way of doing it. So it's basically a comparison metric. The NDCG is a comparison metric. So it's a ranking metric that we use. So based on the number of items, let's say 12 items, so we rank them. So we place our items and then we have our items. So this item that you recommended, did the user click this item? Yes, the user clicked it, correct. So this one, did the user click it? No, the user did not click it. So we add an extra penalty for that. So that's how the NDCG works. We do that for all the items in our recall set, or let me say in our set that we brought out. I don't want to use the word recall set, right? So the set that we brought out, that's how we can estimate the offline LLM, the offline recommendations. But for the online, when we put it in production, we just simply want purchased, right? Items that the user purchased. So did the user purchase this? Yes, that's good to go. Did the user purchase it? No, that's not good to go. Because at the end of the day, what we want to do is make sales. So these are various ways we can evaluate our recommendations.
Kenechukwu, I have a question here about productionizing recommender systems. You told
Okay.
about the concepts of recommender systems. What are the challenges that an enterprise will have when they are trying to productionize it, the MLOps challenges?
Okay. So the MLOps challenges, first of all, recommender systems take, like I said, I started with latency, right? I talked about latency before. When we are productionizing recommendations. So latency. So for a startup, we don't want to have too many systems. We don't want to have too many things that we are running. We want to have just few things so that we can have like low latency, right? So an issue with productionalizing these things is data, first of all. Number one is data. We're going to need data. If you're a startup, you're going to have few data to start with if you're a startup. So that's where you can make use of asking questions to sorry, if I say that word fast, I tend to mix it up. So productionalize these things, right? So you're going to have an issue with data, then data cleaning. You're going to have a way to clean this data and then pass the data to the necessary places to create our features and then build our model and deploy it. So various challenges we have challenges with cleaning the data. We have challenges with latency, which we want to ensure. And then there are things we can take care of, like availability, right? We want to ensure that our our model is always available. We can take care of that by simply replicating, right? We can replicate the models and take care of that. So these are various challenges we're going to have. Data for startups that are just starting, the way to handle this data. Also to train the data. I'm sorry, I forgot mentioning training. So since these data are usually like large, right? Before we can start to get good things. So depending on the algorithm we basically use, the data will end up being large. For something like market basket or so, they can be few, but mostly they are usually large. So for something like that, we are going to need power to train them. So these are various things, challenges we'll have: cleaning the data, training the model, keeping to ensure that we have low latency, which is very important for us. So various problems we're going to have in productionalizing it.
Thank you, Kenechukwu. I would like to open the floor for questions which have come from LinkedIn, YouTube,
Okay.
and those who are here in the Zoom room.
Okay.
Any questions?
No new question. Yash, you answered. In fact, you asked a lot of the questions ahead of everybody else because you know this topic. So it's been fantastic discussion. I don't have anything new that I'm bringing here from LinkedIn. Thank you. And people might come and ask, watch this, and then ask questions. So can you stop the share if you don't mind? I want to see the speakers. So for those watching the LinkedIn or coming back watching the stream, you can still post a question, and maybe we can request our speaker, Kenechukwu, to come and answer directly on LinkedIn. Yep. Okay.
Yeah,
I think
I have
Kenchiko,
one.
it was a
Yes,
good topic discussion. Definitely, it was a good topic discussion. Thank you for sharing this. I'm also curiously interested in exploring the mentorship, or how you can if you have the time to help us on Kaggle experience, and if you can help us with some of those things as well, how we could do that.
Okay, so you mean like talk about how to go on Kaggle?
Yeah.
Okay, how to approach Kaggle problems.
Yeah.
How
Okay,
to get
okay.
your mentorship, how to utilize yourself or other Kaggle mentors on
Okay,
Kaggle.
so Okay, so Kaggle mentorship is actually a program. So it's an annual program that holds, right? So the Kaggle staff themselves usually call for this mentorship program to begin. I think they have one starting in the next. I don't want to give a definitive time since I'm not there, but basically there is a group where these things are discussed, and they definitely announce them. So perhaps on the Kaggle LinkedIn, when they're ready, they're going to announce them. But I'll also put in a word and say that there are people interested and want to know when when the next batch is.
Okay. So in this program, people can be part of Kaggle and be mentored by some of the experts in the industry. Is that right?
Exactly. So the experts in the industry who sign up for the program, yes, you can. In fact, that's the whole point behind it. So it usually lasts for 15 weeks. So you have enough time to ask all the questions you want to ask.
Okay, perfect. Thank you, Kenchiko. Thank you so much.
Yeah.
thank you, Kenchukwu, for the wonderful session. And if you have any parting remarks, we would like to hear.
Okay, so I think that's it for me. I think it was a very fantastic talk, right? Yeah. Also meeting with somebody who has academic experience with recommender systems, I think was fantastic. Us collaborating and finally finding balance on the academic part of it and the industry part of it, right? So I think I like that. Yeah, it was a very good discussion and I enjoyed it. Yes. Thank you.
Thank you so much. Thank you so much. I hope you'll come back because we do this every week with variety of different speakers and topic. So maybe you can come in and be part of our community, and that'll be fantastic.
Sure, I definitely will be.
Thank you, Kenchukwu, for coming for the session and sharing all your learnings with us. And thank you, Sudha, for making this platform available for everybody and for everybody to come here and learn and form a beautiful community of learners. And thank you, Pariya, who is working in the back end and trying to put all this together. Thank you, Pariya Saran. And thank you all the people who came for the session, all the learners, all the students, because Weeklywed is a community, and this community can only thrive when all of you come and participate. Thank you, everybody. Meet you next.
Sorry, Yash. There is one question. I just saw that there is a question on LinkedIn from Rene, one of our students.
Yes.
From one of our students, there is a question on LinkedIn. I just saw that. Can I bring that if you don't mind before you close out, and if our speaker has a few more minutes?
Yes.
So let me bring that back. It was in a different. Okay, so the question is how to decide which one of the 4 methods to use in a real life scenario. Is it common to use a combination of the methods?
Okay, yeah. So from my experience, yes, it is common to use a combination of the methods, right? So from what I said earlier, I said things like market basket are mostly used for complementary items. So if you want to recommend similar items, you're interested in either collaborative filtering or content-based filtering. But if you want complementary items, then you're interested in market basket, right? Well, LLMs are so powerful, they can do any of them, right? They can do any of them. They can do both similar items, they can do complementary items. But for the traditional methods, to build complementary items, you're looking at market basket, and to build similar items, you're looking at collaborative filtering or content-based filtering. Now, how do you choose between them? It depends on what your architecture can support. If you want to make use of user data, which will be large and a bit more expensive, then you're going to go with collaborative filtering. But if you go with content-based filtering, then you're interested in item data, basically, and you do. But the issue there is that you need a lot of background knowledge. You need domain knowledge, right? What the domain knowledge means there is that you need the features of these products. So it's a trade-off. It depends on what you want to use. If you don't want to work hard in getting the domain knowledge, then you're going to have to go with collaborative filtering. But if you don't want to use user data, since it's large, to be able to start going through this thing and expensive, then you want content-based filtering. So it depends on you. But for complementary items, you want market basket.
Yeah, that answers the question very beautifully. And that comes, as I kept telling during the session, it comes from a lot of experience that you have had in real time industry grade recommender systems. Thank you, Kenechukwu. Sudha, do you have any remarks here?
No, I think this was fantastic. It's wonderful. I feel like we've just scratched the surface. It's just amazing. And I worked in eBay with brilliant engineers like Kenchukwu, and we've seen them evolve the recommender systems. But I like this aspect of how it is connected to LLMs, because that was one question that was top of mind for me, saying so much work has been done by industry to build algorithms, recommender
Yes.
systems, and many more, right? And then now when we come and say we are going to do RAG, look at company data, and build out chatbots, then how does that play in? Has been kind of top of my mind, and I'm kind of clawing at it to figure out how it is being done. So Amazon launched Rufus and said, product recommendation, go chat with the bot, right? So that means it's going back to their entire catalog, and they're not going to just query the catalog like you were saying, right? Like a new user who's getting started, right? So I was just thinking, how did they make that? So prompt engineering plays a very important role, right? It's like you're generating the prompt by inserting between the user prompt and the actual LLM, the collaborative filtering or your recommendation engines are sitting in. So I think that creates another challenge for UX designers now, right? Because the user thinks they're asking one thing, you're actually going and asking the LLM something else, and so there is, I think the AIX, aspect actually has to change. So it's beautiful. So thank you so much.
Thank you too.
And thank you, Yash. It was a wonderful session because this was your sweet spot. So you asked all beautiful questions before we could even think about it. So I appreciate that. Thank you so much, guys.
Thank you. Thank you. And catch you in the next Weeklywed.
Thank you all.
Thank
Bye
you.
bye. Bye, Kanchiko. We'll see you then.
Bye.
Bye.
Thank
Bye.
you, Kenchukwu. Thank you,
Yeah.
Sudha. Thank you,
Bye.
Suresh. Thank you, Pariya. Bye.
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 And before we close out, guys, there is a so I've been doing LLM webinars. I did a series of 4. So people were asking, can it be available like a course? So the LLM course is available. Yash, do you want to just share the screen and show them, so people can come just take the 4-part LLM course. It's a 4-hour, not a 4-part. It's all one course. It's a free course and you get a certificate, but you get to learn for real. Here I've posted that link on the chat. It's bit.ly/Jamte LLM course. The name has been created by Pariya. I didn't put my own name in the bit.ly so presumptuously. But thank you, Pariya. Do you want to share that, Yash? Yes. Yeah. It's bit.ly/ Jamte LLM course. So it's just you can just sign up, and take the course, and it'll cover all the 4 webinars I did in the beginning of the year, I think, like starting last year. No, actually, end of last year is when I did that. So it'll cover every aspect of LLM that you need, right from foundation, how it works, and fine tuning RAG as it was by end of last year. RAG is kind of growing, and specifically the chatbot building, what is involved in actually getting to the stage of building chatbots for companies. And there was one more topic about understanding the ecosystem of LLMs and open source versus closed ones and the like. Okay, so with that we can wrap up. Yash, thank you so much.
Thank you, everybody. Thank you, Kenechukwu. And this is just the beginning, Kenechukwu. I hope you are available to answer our questions on LinkedIn and mentor us through getting into a production-ready recommender system.
Thank you.
Thank you. Bye, everybody.
Okay.
We will meet again in the next webinar.